Hi, I'm Axe, and today I and my group mates Mia and Shane will be solving a physics problem. And the problem that we're going to solve is the problem number 1. A 1 kilogram block of copper at 20 degrees Celsius is dropped into a large vessel of liquid nitrogen at 77.3 Kelvin. How many kilograms of nitrogen boil away by the time the copper reaches 77.3 Kelvin? The specific heat of copper is 0.0920 calories per grams degree Celsius, and the latent heat of vaporization of nitrogen is 48.0 calories per grams. So as you can see, the problem is related to the concept of calorimetry and phase change. And the principle of calorimetry is heat loss is equal to heat gain. We use the fact that heat required to change temperature of a certain mass is equal to the mass of material times the specific heat of the material times the temperature change, and that latent heat for this phase change times mass of material that changed phase is equal to heat transfer and heat change. To get the mass of nitrogen that boils away, we insert the second equation into the first equation. So we form the equation Q, or the quantity of heat, is equal to the mass of copper times the specific heat capacity of copper times the temperature change is equal to the mass of nitrogen times the latent heat of vaporization of nitrogen. We will be going to use this equation to solve the problem. So first, we need to identify the value of each variables in the equation. M of Cu, or the mass of copper, is 1.00 kilogram. C of Cu, or the specific heat capacity of copper, is 0.0920 calories per grams degree Celsius, or if we convert this to joules per kilogram degree Celsius, we will have 387 joules per kilogram degree Celsius. And in temperature change, we first convert 20 degrees Celsius to Kelvin, so we have 293.15 Kelvin and 77.3 Kelvin. And lastly, the latent heat of vaporization of nitrogen is 48.0 calories per grams. We'll need to convert this to joules per kilogram, so we'll have 2.01 times 10 to the power of 5 joules per kilogram. So if we substitute all of this, we will have 1 kilogram times 387 joules per kilogram degree Celsius times 293 Kelvin minus 77.3 Kelvin is equal to mass times 2.01 times 10 to the power of 5 joules per kilogram. Now, don't you may be wondering how to solve this equation, since clearly it says that 1 kilogram times 387 joules per kilogram degree Celsius times 293 Kelvin minus 77.3 Kelvin is equal to mass times 2.01 times 10 to the power of 5 joules per kilogram.
Aha!
We actually have to compute the first equation first. So in this case, if we compute 1 kilogram times 387 joules per kilogram degree Celsius times 293 Kelvin minus 77.3 Kelvin, we will have 83,475.9 joules. And then we'll compute 2.01 times 10 to the power of 5 joules per kilogram, so we'll get 201,000 joules per kilogram. Next, we'll divide both, so we'll get 83,475.9 joules divided by 201,000 joules per kilogram, which is equal to 0.41530298507. We'll just round this off to 0.415 kilograms. So there we have it. The amount of nitrogen that boils away by the time copper reaches 77.3 Kelvin is 0.415 kilograms of nitrogen.
Thank you for watching.